Once again to my YouTube channel Knowledge Entertainment, and now we are moving to the second part of the lecture of complex numbers and quadratic equations. In the previous one we have discussed about the properties of complex numbers, especially properties of addition, properties of multiplication, and properties involving both addition and multiplication. So now we will move ahead and I'll start with the topic of Argand diagram. So what is an Argand diagram? So this is Argand diagram. Argand diagram means every complex number z, x plus iota y, can be represented on this plane. This is x-axis, this is y-axis, and this point x plus iota y is a replica of the coordinates x, y. That means you take x on the x-axis, this distance, and then move on to the y-axis having distance y, and this point will be called x plus iota y. That means your point with coordinates x and y will represent the complex number x plus iota y. This plane is called the Argand diagram, Argand plane. And one more thing, because the y-axis represents the imaginary part, that means y is imaginary part of z, and x is real part of x. X is represented on the x-axis and y is represented on the y-axis. So we also call this x-axis as a real axis, because on this axis we represent the real part of the complex number, and y-axis is also known as imaginary axis. Imaginary axis, because on y-axis we represent the imaginary part of the complex number z is equal to x plus iota y. So this is our Argand diagram, and once again, this point P, this is your origin O. Join O with the point P, draw the perpendicular on y-axis, this is your distance x, this is y. If this angle is theta, then you take this as r, this distance OP as r. Now this point I am denoting it by m. Look at what is OM upon OP. If you consider this angle theta, then OM is your base and OP is the hypotenuse of the triangle OMP. So you are getting base upon hypotenuse, that means cos theta. That means OM is your x, so x is equal to OP is your r, cross multiplying x is r cos theta. Similarly, your MP, or you can say PM upon OP is sin theta, because it is perpendicular over hypotenuse. Once again, PM is y, OP is r, by cross multiplying y is r sin theta. Now your complex number z was x plus iota y. Substitute the values of x and y recently obtained. So what you will get? You will get r cos theta plus iota into r sin theta. So r can be taken out and it will become cos theta plus iota sin theta, and this cos theta plus iota sin theta, sometimes we write it as cis theta. So it is r cis theta, and this cis is very much clear. It is cos plus iota sin theta, and this form of the complex number z, where it is written as r cis theta, r is the distance of the point from the origin and theta is the angle made by the line OP with the positive direction of x-axis. This form of z is called polar representation of the complex number z is equal to x plus iota y. So what we have covered just now, Argand diagram and representation of a complex number in polar form. Once again, before rubbing it, if you square and add these two, what you are going to get? This is your r square sine square theta plus r square cos square theta. So r square can be taken out. You will get cos square theta plus sine square theta. That means what you are having, r square cos square theta. Square of this is x square plus you are getting r square sine square theta. R square sine square theta means square of y square. So it is plus y square. Now cos square theta plus sine square theta we know is 1. So you are left with r square into 1, that means r square is equal to x square plus y square. This means your r is under root x square plus y square. And this we also know that r is the distance of the point O with P. O is origin 0, 0 and P is the point x, y. So what will be the distance between O and P? Will be x minus 0 whole square plus y minus 0 whole square root. That means under root x square plus y square, which we once again obtained here. And this r in the polar form, when you write the number z as r cis theta, then this r is called modulus of the number z and is usually denoted by mod z. So what is this r? This r is your mod z. R is your mod z. And what is your theta? So once again, look into this triangle OMP. Your PM upon OM. PM upon OM. PM upon OM means perpendicular over base. And perpendicular over base is tan theta. According to the trigonometry, in a right angled triangle, perpendicular divided by base is equal to tan theta. So this is tan theta. Now PM is the distance y over OM is the distance x. So what is your theta now? Your theta is now tan inverse y upon x. And this theta, when a number z is represented in the polar form r cis theta, this theta is called argument of the complex number z, and we usually denote it as arg of z. That means argument of z, and argument of z is tan inverse y over x. So till now what we have learned about the organ diagram, about the polar representation of a complex number, about modulus of a complex number, and about argument of a complex number. Now we'll move ahead. Next, there are two important properties of argument of z. So one of the properties is that argument of product of two numbers z1 and z2, where z1 and z2 are both complex numbers, then argument of z1 into z2 is argument of z1 plus argument of z2. Similarly, there is the second property, argument of the number z1 over z2 is argument of z1 minus argument of z2. One thing is clear, that we are talking about z1 upon z2. So z2 must be a non-zero complex number. So for a non-zero complex number z2, we are having argument of z1 upon z2 is equal to argument of z1 minus argument of z2. We have already mentioned the properties of mod of z in our previous lecture, and now we have seen two important properties of argument of a complex number. Next, before moving on to the question, I'll discuss the solution of a quadratic equation. So first of all, what a quadratic equation is. A quadratic equation is an equation of degree 2 in a single variable x. That means an equation of the type ax square plus bx plus c is equal to 0. This equation is called a quadratic equation in the variable x. Now how to solve it? So what we have to do, we have to find the possible values of x that satisfy this quadratic equation. So first of all, multiply this equation throughout by 1 upon a. So multiply by 1 upon a both sides, you will get x square plus b upon ax plus c upon a is equal to 0. Now take this c upon a to the other side, that means to the right hand side. What you will get? You will get x square plus b upon ax is equal to minus c upon a. I am writing it a little bit further. Minus c upon a. This method what we are doing, you know it very well that this method is known as the method of completing squares. So what we are to do? We are to complete square on the left hand side, and whatever the part we will add to make it a complete square, we will also add the same part on the right hand side. So what you have to do? You are to add square of half of the coefficient of x, because the coefficient of x square is 1. You have made it a monic polynomial. Now coefficient of x is b upon a. So what will be half of it? Half of this will be b upon 2a, and now you are to take square of that. So square of that is b square upon 4a square. Add b square upon 4 square, 4a square both sides. You will get here plus b square upon 4a square. Also you will get b square upon 4a square on the right hand side. What you are looking at into the left hand side, it is x plus b upon 2a whole square. A plus b whole square is a square plus b square plus 2ab. On the right hand side, take 4a square as LCM and you will get b square minus 4ac. Now, take square root both sides. What you are going to get? X plus b upon 2a is equal to plus minus square root of b square minus 4ac over square root of 4a square is 2a. Take this b upon 2a also to the right hand side and take LCM 2a. So what you will get? You will get x is equal to 2a is LCM minus b plus minus under root b square minus 4ac, which will give you two values, two different, maybe equal, maybe real, maybe complex, maybe rational, maybe irrational. So you will get two values for x from this expression on the right hand side, and these will be the roots of the equation which we have mentioned in the starting, that is ax square plus bx plus c is equal to 0, and that will be the solution of this quadratic equation. Now this term within the square root, that is b square minus 4ac, it is called discriminant of this quadratic equation. So what we are writing now, b square minus 4ac, and we will denote it by d, as it is called discriminant of this quadratic equation. Now, roots of this quadratic equation depends upon the nature of this d, this discriminant. If your d is strictly greater than 0, that means positive, then roots will be real and distinct. Roots will be real and distinct. Further, I am classifying this d greater than 0 into two parts. One is d is a perfect square. D is a perfect square, and second classification is D is not a perfect square. So two classifications of first case. In the first case, when D is a perfect square, here roots will be rational and distinct. And in the second case, when D is not a perfect square, here roots will be irrational and will occur in pair. And will occur in pair. In pair means if one of the roots is a plus under root b, the other will be a minus under root b. That means they will occur in conjugate pairs. In the first case, roots are rational. In the second case, roots are irrational. But whether rational or irrational, they will be real. So why these two are the sub cases of the case d is greater than 0. Then we'll move on to the second case when the discriminant is 0. If d is 0, discriminant is 0, then roots will be real and equal. Because your discriminant is 0, both the roots will be minus b upon 2a, because the second part d under root b square minus 4ac will become equal to 0, and both the values of x you will obtain will be equal to minus b upon 2a. So the roots will be real and equal. The third case, if your d is strictly less than 0, that means negative, and you know that if your d is negative, suppose the value of d is minus e, where e is positive because d is negative. So what will happen to your under root d? Your under root d will become under root minus e. So it can be written as under root e into under root minus 1. So that means iota into under root e. So that means the roots will be now imaginary. And since you are having a plus minus sign here in the solution, your solution is minus b plus minus under root d upon 2a. So I am considering this plus minus sign. So here is plus minus sign. That what it will make, what it will give? It will give you two roots as complex conjugates of each other. If one of the roots is a plus iota b, the other will definitely be a minus iota b. So what will be the roots? In this case, your roots will not be real, or you can say root will be imaginary. Roots will be imaginary and will be complex conjugate of each other, and will be complex conjugate of each other. This is the basic theory of solution of quadratic equations. But now we will move on to the questions of complex numbers as well as questions of quadratic equations. How to solve various questions. So one of the questions I am going to take here, very simple question. The first one is simplify 1 plus iota raised to the power 21 plus 1 plus iota raised to the power 22 plus 1 plus iota raised to the power 23. Now, to simplify it, you need not to open these powers 21, powers 22, powers 23 and so on, because if you solve 1 plus iota square, what you are going to get is 1 plus iota square plus 2 iota, a square plus b square plus 2ab, and this iota square is equal to minus 1 will be cancelled and this will become equal to 2 iota, and this will help solving this expression. So I am writing the first term as 1 plus iota raised to the power 2 raised to the power 10 multiplied by 1 plus iota. So 2 power 10 will become 20 and one more power, that means power 21. The second expression I am going to write it as 1 plus iota square raised to the power 11. And the third one, as I have written the first one, I am going to write it as 1 plus iota square raised to the power 11 multiplied by 1 plus iota. Now look at what it is becoming. This 1 plus iota square was 2 iota. So it is 2 iota raised to the power 10 and 1 plus iota plus. This is simply 2 iota raised to the power 11, and here you are having 2 iota raised to the power 11 into 1 plus iota. 1 plus iota is still there in the first term and in the third term. So 1 plus iota can be taken out. 1 plus iota can be taken out. Also, 2 raised to the power 10 is here. 2 raised to the power 11 is here. So 2 raised to the power 10 can also be taken as common. So 2 power 10 is common. 1 plus iota is common. What you are going to get is iota power 10 now within the bracket. And this iota power 10 can be written as iota square power 5 plus the last term now. 1 plus iota is outside, 2 raised to the power 10 is outside, so 2 will be there, 2 will be there, and iota power 11 will be there. So iota power 11 you can write iota square power 5 and 1 iota is left. And the middle term, don't forget this term, this is 2 raised to the power 11 and iota power 11 once again is iota power 2 raised to the power 5 multiplied by iota. So what is left now? 2 raised to the power 10. So if I write the value of 2 raised to the power 10, 2 raised to the power 10 is, I think, 1024, if I am right. Then 1 plus 2 iota, 1 plus iota, and in the bracket, this iota square is minus 1. Minus 1 raised to the power odd natural number is minus 1 plus 2 into, once again, minus 1 raised to the power odd natural number is minus 1. So this is minus 1 and 1 iota is there plus 2 raised to the power 11. 2 raised to the power 11 is 2048, and once again minus 1 raised to the power odd natural number is minus 1 into iota. Now what we are to do? We are just to simplify using our basic calculations. This is your 1024 and this is your 1 plus iota. In the bracket, what you are going to get is minus 1, and the second term is 2 into minus 1 into iota is minus 2 iota plus 2048, and this is minus 1 into iota is minus iota. Once again, 1024 is here, 2048 is here, so you can take 1024 as common from both these terms. Here you will be left with this product and I'm going to multiply these two to write it in the next bracket. 1 into minus 1 is minus 1. 1 into minus 2 iota is minus 2 iota. Minus 1 into iota is minus iota. And iota into minus 2 iota is minus 2 iota square. But since iota square is minus 1, it will become plus 2. And this is minus sign. This 2048, 1024 is common, so you will be left with 2 and 1 iota, so it is 2 iota. And we are probably in the last terms, in the last part of the solution. This minus 1 plus 2 is 1. This minus 2 iota, minus iota and minus 2 iota is minus 5 iota. And this is the value of the given expression we have started with. So I request you to like my videos, to share this channel with the +1 needy students who have taken mathematics as an optional subject, and subscribe my channel to be continued here for the updates related mathematics, related other types of knowledge, related astrology and so many other things. Leaving you here, I'll have to make you once more request to please see the previous video before solving this one. And I think if you have seen the previous one, then definitely you will like this one. Thank you once again.